Welcome to INA Insights, where prominent leaders and influencers shaping the industrial and industrial technology sector discuss topics that are critical for executives, boards, and investors. INA Insights is brought to you by INA.ai, a firm focused on working with industrial companies to make them unrivaled segment of one leaders. To learn more about INA.ai, please visit our website at www.ina.ai.
Hi everyone, and welcome to another episode of INA Insights. Today we have with us Mr. Shailesh Upreti, who is the founder and CEO of C4V, a lithium-ion battery technology company possessing critical insight related to the optimum performance of lithium-ion batteries and gigafactory designs. Shailesh himself is a pioneering expert in lithium-ion technology, leading advancements like the innovative Lyser platform and developing cutting-edge battery solutions. Shailesh, delighted to have you with us today and a very warm welcome.
Thank you. Thank you very much. Thanks for having me.
Awesome. So why don't we get started with you explaining a little bit about what C4V does?
Yeah, so C4V is primarily focusing on deploying gigafactories, which in principle are the large plants that produce lithium-ion battery cells. And our focus is to deploy these factories in emerging markets. We feel as the new energy innovation, the clean tech and climate tech evolves, these gigafactories going to be the central point for economic growth, as well as meeting the climate targets that each country is setting up. We see that big brands have been focusing on, let's say, big markets where 50, 100 gigawatt hours are kind of the bare minimum size they deploy. Our goal is to get into 2 to 10 gigawatt hour and eventually scale, which has a lot of void globally today. So that's what C4V does. And, we bring everything in terms of the product design processes, a fully qualified and mature supply chain, and to some extent market de-risking as well, where we have end users who have been using batteries and signing up contracts to buy these batteries from these factories.
Got it. And when it comes to the locations, so you mentioned that these gigafactories are based in emerging markets for C4V. What are some of the drivers of that decision?
Yeah, so our business model is quite unique in a way that it's similar to like Intel Inside, right? So we bring the whole package and we unlock the value for our partners and customers, you can say it. And in that, or the easiest way to understand, it's like McDonald's model. It's a franchise model where anyone who is an upstream supplier to automotive industry or any industry for that matter wants to get into EV component supply chain or renewable energy supply chain. So we unlock that potential for them. We bring the entire package. So in that, we are primarily serving as a technology partner, and we identify these local partner in these countries, which eventually become the operating partner for us for these gigafactories. So we remain the technology engine, and then they drive the business and the entire local operation. So that said, any market like India would be one example where there's no gigafactory today. There are various in making. So it's a new industry. Eastern Europe, some of the Southeastern Asian countries, Australia, South America. So some of these markets, big players like LG, Samsung, CATL, they are not really focusing some of the markets. So we get into these evolving and, let's say, untapped market.
Makes sense. And Shailesh, you're also the founder of another company named IM3NY. So how do the two companies go together for you?
Yeah, so IM3NY is the actual gigafactory that is operational here in Binghamton, which is upstate New York, about 3 hours from Manhattan. And that plant is our first facility where the cell manufacturing happening today with C4V technology. So you can call it the American factory because America I call and consider very much an emerging market when it comes to cell manufacturing, because there's no true domestic cell manufacturing plant here in the country today. particularly with the new age technology like phosphate chemistry, advanced phosphate. There is no factory. So IM3NY is a manufacturing facility that is producing lithium-ion cells here in the US with C4V's technology exclusively licensed to IM3NY.
Got it. And it looks like both of these companies are making significant strides in the energy storage space. Can you talk a little bit about some of the advancements that are in the works?
Yeah, so as you can imagine, energy storage has been moving very rapidly and becoming part of our daily life. You know, the easiest example is your headphones, right? It has gone from wire to wireless, and the batteries are unlocking that. Your smartwatch, your mobile phone, everything is, we used to, I give example, like we used to have like one cell phone in a family. Now you see multiple cell phones, multiple headphones, multiple laptops. And so the consumption is increasing per family of you can say per capita. And as a result, as the migration from portable electronics to solar and wind, as well as electric vehicle happening, we see energy storage as the backbone for those markets to succeed, right? And in that, each market require a little more customization and a very different, let's say, product design, but the core concept, majority of the components are similar. You do change and tweak certain things, but the overall manufacturing process, the chemistries are within the same families. And so we try to focus on two areas. One, obviously the chemistry itself. So we have our first generation product is a cobalt and nickel free tech. It's a higher voltage phosphate chemistry that delivers 20% more energy than a typical LFP, which is the most popular technology today otherwise. And most of it is produced in China. And the second is the cell design and cell processes. So you mentioned about the Lyser. It's one of the most innovative designs that you can say we have come up with. It's a patented tech that allow us to design a product irrespective of the power and energy needs. So mostly if you go in a high power market, you will have to custom design a cell for the power application. And this particular design actually allow us to tap into power and energy both from a single design, which also de-risks some of the manufacturing side of making it available.
Got it. Got it. And your solutions, Shailesh, how do they integrate with the existing energy infrastructure?
Yeah, so because we sit at the midstream of the value chain, right? So upstream is, let's say, mining and refining and all the chemical side. And then downstream, you'll see whether it's a portable electronics, which we don't focus, heavily today, but renewable, which includes all the grid storage, home storage, CNI space, commercial, and industrial applications. So that's the energy storage where you'll store energy when it is cheaper, including from solar and wind when it is available. And then the other is the electric vehicle segment, where from scooters to three-wheelers to cars, and eventually we see buses and trucks and trains running on full battery power, drivetrain. And then the third segment, which is evolving very slowly, but I see will be, I think, moving very fast in next 5 year to 10 year time frame, is electric aviation. So all the aircraft system running fully powered by batteries. So we focus on these segments, and how we integrate in that is because we are midstream. So our design, the product that will fit, let's say a car, if C4V battery has to fit in, we have a drop-in solution available today. So whether you go to Lyser or our tabless prismatic cell, we could, we can take any existing car or bus and take the battery out and pretty much drop in our system and make it better. So that's the easiest way to understand how we are kind of a drop-in approach, which also mean we can help OEMs and new companies who wants to get into EV with a product that deliver them the chemistry advantage without complicating the system design.
Right. And Shailesh, this is a very hot space that you talk about, batteries for electric vehicles, for portable devices, and hopefully in the future for aviation sector as well. How is C4V differentiating itself? Because I imagine it's also a very competitive space right now.
Yeah, it is indeed. And I think one of the two ways, right? One, with our unique chemistry, which allow us to produce a product at the lowest possible cost. In fact, we are even cheaper than the cheapest available in the market today when it comes to cost and affordability. So that really gives us a very strong edge in the market, that we are next generation technology, but not 3 times the cost. We in fact lower than the existing products in the market. Second is our innovative business model. So one of the ways we feel to penetrate this market and compete with likes of LG, Samsung, or Panasonic, who are already in the market for 30 years, is to really address these emerging market needs where their focus is minimal, and we don't have to, you know, go through all the challenges, whether it's environmental, labor laws, and overall operational challenges in a country. So we tie up with a strong operating partner locally, and that gives us a boost in the market. So think about this: a train that is running 30 miles an hour, and you add another engine in front that will unlock a 60 or 100 miles an hour speed. So we are that engine that we are not restarting the whole train. We are not building a new track. So we are working with these partners who are scaling. So that's basically have affordability aspect to the product, and then making that available through the channels where we partner with local companies in these markets. Other two ways we feel we are unique, and there's no one across the globe. I mean, there are a few Chinese companies who are trying to do it this way, but we have no competitor at C4V level. No one offers a giga scale production solution today. There are solutions, but they are only 1/10 of the solution, and you have to work out the whole nitty-gritty, and it takes 5-10 years to really go from a product component to a product manufacturing and scale. So that's how we feel we have a little more advantage over many other. And this advantage comes not because we have deployed a lot of capital, but because we have spent a lot of time. There's no shortcut in this market, because these batteries are directly connected to human life, and they have to go through a very stringent test program and validation. And product got validated by US military, first customer, into US Navy. And since then we have been making safety and security of our batteries as a core part of the innovation. And so we feel, I think, having a low cost, making it available, and make sure that it's safely delivering the energy are the key aspect to a successful business setup.
Right. And Shailesh, this affordability part of it, the cost efficiency, of course, being located in emerging markets for your manufacturing helps. But how do you at the same time ensure the product quality and the innovation also keeps pace while you are based out of there?
Yeah, so I mean, that's where I think, because we had the agility of a startup. So when we started the company back in 2012, we really started with a clean sheet, and we said, okay, there are different form factors. So if you buy, let's say, example, if you buy Tesla Model X, the early version, you may see a capsule, which is, we call 2170 cell. It's like a cylindrical cell. As you go to new cars, it is moving from that smaller capsule to bigger capsule, which is 4680. Like, you change the diameter and the length and the height, whatever. And then the Tesla has been now coming up with the affordable vehicle where they are replacing those with prismatic cells, right? So in principle, what I'm trying to say is, as you open these batteries, there are different form factors inside. And one of the biggest challenge for people is, hey, what happens if you build a $2 billion factory and technology change, right? That's biggest fear when you deploy $2 billion in a emerging market. You don't want that factory to be obsolete in 5 years. It has to run for 20 years. So that's really the problem we have solved. Our product design and our blueprint of the plant, which is the factory design, Both are modular in nature. What that allow us to do is integrate different chemistries and innovation. So we are not married to one tech and one design. So that really unlocks our potential. So think about this more as a razor blade. So it's keep changing the blade, but you still use the same razor for 20 years, right? So that's kind of the aspect we have integrated into cell manufacturing, which not many people do today. They, because they are legacy players and they have, this 30 years of learning, and also their products are already in the market for long, and for them to change anything is a big challenge while they are slowly adopting it. But I think our ability to move fast as a startup and offer this has really played an important role. And then affordability side actually is connected to that. So if we are able to build a plant that is agnostic to chemistry and can be scaled faster, plus it comes with all our strong, stringent quality control metrics. So we have a digital product. It's called digital DNA, which in principle, I call it a tool that allow molecules to speak to machines. Basically, all these materials that flow on the production floor, they can actually talk to equipments and then make sure that the quality is met, right? So we are integrating a more advanced and self explanatory self-learning tool that will, irrespective of which country you are and what language you speak, um, make sure that you're able to achieve the utmost quality specs, right? So it's so automated that, and self-learning that it makes sure the cost control is there, quality is met, and then you're able to scale rapidly. So all that then goes back to your basics. If your basic raw material cost is same or lower than your competitors, and you are able to control the production facility way better, then eventually your cost of product going to be in tight control as well. So that's our philosophy. So that's how we deploy this.
Got it. And Shailesh, there's a lot of talk about AI and industrial IoT as emerging tech trends these days. How does that impact the lithium-ion battery technology space, if at all?
I mean, it does. I mean, I think I would say every manufacturing is getting upgraded, right? Every technology that we use today is upgrading, and that putting a lot of pressure on manufacturing side, right? Ecosystem. So industry 4.0, even people talking about beyond that, building digital plants before you build a real plant is a very common practice today, right? So you, in principle, use the computing power available. In old days, if you had a pipe to go through a different channel and you build it and you realize, hey, I have to now open the whole wall and kind of redo the whole thing, and it takes another 6 months. Now you could actually make that mistake on computer and learn from it, so that you can fix it in 5 minutes. And when you build the real plant, there is no mistake, right? So that's starting from there, like the conceptual stage where you're using the digital tool and simulation tools, to then building that plant and then running that plant digitally, which is where I think IIoT and all the automation takes place, and is very important. I think that has started. I would say integrating into lithium-ion manufacturing as well. It has helped a lot. Companies today are able to achieve 90+% yields. It used to be 60%, 70% yield. So there's a lot of improvement in quality because of no human touch, a lot of automation. And then I think what we are seeing the trend, and that's where our digital DNA tool that I talked about, it's a product in itself. And irrespective of any factory, this tool can be deployed. And it's really the data science side of the matrix, where if you are producing product, you along the way collect a lot of data, whether it's the process data, whether it's spec data, whether it's how and who operated, whether it's environmental data. All that data come together and eventually impact your product performance. So you start monitoring and measuring and collecting these data, and then eventually I think use it in your favor by whatever logics you put in place, which you can call AI, you can call it machine learning, or harnessing the data you already have to benefit your production yields. And that's what we do with digital DNA. So digitize the quality control, automate, and then collect the data and use that in our favor for production facility.
Understood. So, Shailesh, before we bring this to a close, just want to switch gears to your own background a bit here. So, tell us a little bit about your life before C4V and what has inspired your interest in this energy storage space.
Yeah, so I'm originally from India, a northern part of India, a place called Uttarakhand. And I'm from a small town, Manan, Almora. That's the foothills of Himalayas. Eventually, studied various part of the country, graduated from IIT Delhi, then got opportunity to work with Professor Arunachalam Ramanan. He's a well-known material scientist, and then eventually also worked with Professor Stan Whittingham, who invented the lithium-ion battery tech, also won the Nobel Prize in 2019. So that really gave me a very strong technical pedigree, which helped me understand the value chain very well and what the chemistry mean and how you tailor them to your needs. Also have business degree, MBA in international business management. After working with Stan, I moved upstream in a chemical plant and cathode, which is one of the most cost intense component. And then became entrepreneur after that. So for last, I would say 12 plus years, I've been, I did my first venture into recycling, then started C4V in 2012 timeframe. And, since then it has been a very exciting journey. I think energy in particular excited me because I feel very similar to pharmaceutical industry, healthcare industry. Energy is the integral part of our life, whether going from point A to B or our day-to-day activities, we need a lot of energy, and the natural resources are depleting, whether it's a coal or petrol or diesel, whatever gas, natural gas, everything is, we have been extracting is so much that it's it has its own limit. It comes with a definite size, and we have been burning it for 100 plus years. So we do need to find solutions. So that's really was the key motivation. And I thought energy storage, with my chemistry background, and I felt like I got attached to this very early on. And I think I made it my key passion, and now pretty much 24/7 into it.
Perfect. And Shailesh, with that background and your experiences with C4V and IM3NY so far, what's your sense on the outlook for lithium-ion battery technologies as such?
Yeah, I think the future looks great, irrespective of many competing technologies. I feel the various version of lithium ion, whether it's a solid state, whether all different other techs, that sodium, lithium, or lithium sulfur, or other tech competing. I see that lithium ion is there to prevail for next 30, 40, maybe 50 years, in different forms, of course. And you would see more and more of these batteries on the road, on the sky, in house, in your hands. So I think that's how I see the industry and evolving, and making it affordable for common people.
Great. Thank you so much, Shailesh. It was lovely to have you and talk about the energy storage and lithium batteries technology space. And
thank you very much. Thanks
perfect.
for hosting me today.
Thanks for listening to INA Insights. Please visit ina.ai for more podcasts, publications, and events on developments shaping the industrial and industrial technology sector.